Hello everyone, welcome back to my YouTube channel. This is Monisha.Chandrashekhar, currently pursuing my engineering in Sri Venkateswara College of Engineering, Bangalore. My USN is 1VE23CY031 from the section Galfin. So the topic is analysis of probabilistic models, which is based in mathematics. So let us begin the session. Let us see what are we going to cover in today's topic, that is what is probabilistic models comes first, then some of the examples of probabilistic models, and the third comes the types of probabilistic models. So let's begin. So before getting to know what is probabilistic model, first let us know what is probabilistic. A probabilistic method or a model is based in a theory of probability or the fact that randomness plays a role in predicting future events. The opposite is deterministic, which is the opposite of random. It tells us something can be predicted exactly without the added complication of randomness. Now let us read what's probabilistic model. So probabilistic models incorporate random variables and probability distributions into the model of an event or phenomenon, while a deterministic model gives a single possible outcome for an event. A probabilistic model gives a probability distribution as a solution at the end. So these models take into account the fact that we can rarely know everything that is about a situation. There's nearly always an element of randomness to take into account. For example, life insurance is based on the fact we know that we certainly will die one or the other day, but we don't know when we're gonna die. So these models can be part deterministic and part random or wholly random. Can't tell anything. So let's move on. Some of the examples here. So like suppose there are five marbles in a bowl. One is red, one is blue, one is yellow, one is green, and one is purple. If if one marble is to be picked at random from the bowl, the sample space possible outcomes, that is S, is red. It might be any of the colors like red, blue, yellow, green, or purple. If three of the marbles are red and two are blue, then the sample space would be red and blue. Since only two possible color outcomes will be possible, if instead two marbles are picked from the bowl with three red marbles and two blue marbles, then the sample space would be two red, two blue, one red, and one blue. It might be two red or two blue, or it might be one red and one blue. So these are the possible outcomes. The set of all possible outcomes are given over here. So suppose there are three red marbles and two blue marbles in a bowl. If an individual picks three marbles, one at a time, from the bowl, the event pick two red marbles can be achieved in three ways. So the set of outcomes would be red, red, blue, blue, red, blue, red, red. That means like the way you pick up the colors, it might change in this order, like red, red, blue, blue, red, red, and so on. Like that's the basic sample space, like outcome. The sample space for picking three marbles one at a time is all of the possible ordered combinations of three marbles, that is red, 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 blue, red, blue, red, blue, red, red, blue, blue, red, blue, red, blue, red, blue, blue. Since there are only two blue marbles, it is impossible to achieve the event blue, blue, blue. Okay. Now, this is for the reference. One more example where the probability rule, to find the probability of an outcome, multiply the probabilities of the branches. Like first flip, you might get a chance 0.5% of heads or 0.5% of tails. It can be a chance of both. Then the outcomes might be heads, tails, heads, tails, or anything. So the final calculation, when you do it, you get the probability as 0.25. One more example, you can go through this, where you have a bag of jelly beans in six colors, that is green, orange, blue, red, yellow, and brown. It is somewhat similar to the marble question. But here we have determined by performing a number of trials that the probability of picking a particular color over here. There we had two blues and one red, or like two reds and one blue. So here it can be any color. You can pick any color. You don't know which color you're gonna pick. So that probability is found here. So when it comes to types of probabilistic models, now as we have already discussed what probability is, and now it's time to discuss the types of probability. You read it right. Yes, there are three major types of probabilities, and those are theoretical probability, experimental probability, and axiomatic probability. So in the beginning, let us go through theoretical probability. So theoretical probability is based on the chances of something happening. We can also say that it is based on the possible chances of things happening in a particular problem, or a previous events, or a real life situation it might be. The probability is basically based on the basic reasoning open probability. One of the example is, suppose we are tossing a coin, like we saw the previous example. We are tossing a coin, and as we have discussed above, the single coin has only two outcomes. Either it shows heads or it shows tails. So the probability of getting a head or a tail is equal, and that is 0.5. So this was all about one of the most common or basic type of probability, that is theoretical probability. Next comes experimental probability. The name suggests that it is experimental. It means it will consist of some experiments in this type of probability. Basically, we can say that the experimental probability is based on the observation coming from an experiment. In order to get an answer from such a type of probability, there must be an experiment going on, and from that we will account or observe the outcomes, and then we will get to know about the probability of any event from that particular experiment. Let us go through the example. If we toss a coin 10 or 15 times, then the 10 or 15 times are the trials, and now how it will get done, how it will be get done. So suppose we toss it 10 times and the head is recorded 7 times, then the experimental probability of the head will be 7 by 10, and the experimental probability of tails will be 3 by 10. The last one is axiomatic probability. These are the set of rules. There are set of rules in axiometric probability, or we can call those sets of rules axioms. These rules get applied to all the types of reasons for a set of rules known as Kolmogorov's three axioms. With the help of axiomatic probability, we can calculate the chances of occurrence and non-occurrence of any event. Let us go through the example so that you can get a clear understanding of axiomatic probability. The events, the die comes up 1 and the die comes up 4, are mutually exclusive, assuming we are talking about the same toss of the same die. The union of events is the event that at least one of the events occur. So this brings us to the end of this session. Thank you so much for listening to this session. Please do like, share, subscribe to my YouTube channel, and this might help for my studies. Thank you.